Let's at least get cosine down. I'm just going to focus on mostly the positive x this time because I know what it's going to be anyways. All right, if you go out 0 to 2 pi, so I don't need that much, but there's pi over 2, there's 3 pi over 2, and you're going to need to go out on the y-axis, same thing. Let's go out 2 pi, half of that's pi, half of that's pi over 2, and then 3 pi over 2. All right, where does sine start? Where does cosine start? It starts at the top. It starts at 0, 1. So it's going to be roughly, and I'll do it in red, so roughly right here. And then where does it go? Middle. And I am going to need negative pi over 2. And then negative pi just for measure. All right, then it goes to negative 1, right? And then it goes back where? Middle, and then goes where? Top. Okay, so here's what we get for cosine, and we know it keeps going forever. And it's a function. We can keep graphing it forever and have no problems. Now let's flip it. So what does 0, 1 become? 1, 0. And I'm going to do it blue. This one I'm going to do really good, okay? 1, 0 about right there. Okay, what about the next one? Pi over 2, 0. 0 pi over 2, so roughly right here. Okay, what about the next one? Pi, negative 1. What is it? Negative 1. Sorry. So pi, negative 1, so it'd be negative 1 pi. It's about right there. What about 3 pi over 2, 0? 0, 3 pi over 2. And then 2 pi, 1. 1, 2 pi. So roughly, if you were to dash it, it looks like this. Okay? How much of it do you need for it to start repeating?
Pi over 1 to negative 1 pi.
Look at the y values.
Pi.
0 to what?
Pi.
0 to pi. 0 to pi is going to be the part of the inverse cosine graph that you'll actually look at before it fails to be a function. So this part right here, that's the only part we want to look at. Okay? And then if you look at just this red part, and then if you look at it, if I draw that y equals x line in, you can kind of see that it's reflected over that line y equals x. Okay, you can see that this red part, you flip it over the line y equals x will match up with that blue part. Okay? So that much, I mean this thing, we know it goes on forever, but if it goes on forever, it's not a function. So the calculator built in knows that for it to be a function, it's only going to use in the range 0 to pi. So let's go over this. Domain for cosine was what? All real numbers. What was the range? Negative 1 to 1. Come over here. Inverse cosine. What's the domain? What's the domain? Negative 1 to 1, which is the same thing as inverse sine. Inverse sine and inverse cosine have the same domain. You can't take the inverse cosine of something bigger than 1. You can't take the inverse cosine of something less than negative 1 because on the unit circle, the biggest cosine ever is 1 and the smallest it ever is negative 1. So if you try and do inverse cosine of 3 right now on your calculator, you're going to get an error. But the ranges are different. The range is different. What's the range going to be? It's not going to be all real numbers because we know it can't go on forever. It won't be a function. 0 to pi. Your calculator will only spit out answers from 0 to pi, which is nice. It's nicer than inverse sine because inverse sine gives you some negative ones sometimes, and sometimes I might not be asking for the negative ones. I might be asking for everything from 0 to 2 pi, which is all positive. At least cosine gives you the positive ones. Okay? And what's interesting, though, is later on is when we get to this tomorrow and you get an answer in quadrant 2, like let's say you get 2 pi over 3 is the answer. Let's say you do cosine, I'm not even going to think about it. Let's say you get 2 pi over 3 as the answer. To get the other answer, you're going to have to find the reference angle off that one, which would be pi over 3, to find your second answer. Decimals, it's a little more complicated. As you find the reference angle off a decimal, you got to know how to use that reference angle because it's not going to be a common angle, so it's a little weird. All right, so there's cosine, there's inverse cosine. This is the big thing you've got to memorize. I'm trying to hammer that. So what was it for inverse sine? Going to need it for tomorrow. Negative pi over 2 to pi over 2. What is it for inverse cosine? 0 to pi. Last one, tangent. Now, they got this one. I had about half of them out of the 8. There's only 8 of them, but half of them got this one. Let's see if you can do this one. So graph tangent. I'll start graphing it up here, and let's see if you can come up with what inverse tangent would be. This one's interesting. It's different, but looks a little weird. Because you got to know what you're going to do with those vertical asymptotes when you flip, or when you switch x and y. And I'll go ahead and give you a hint. Just do from negative pi over 2 to pi over 2. Graph tangent from negative pi over 2 to pi over 2, because those are where the asymptotes are at. So you usually start with one period, which is pi. Then you go half of that's pi over 2. But I'm only going to ask you to graph from negative pi over 2 to pi over 2, and then go ahead and work your magic. Is he going Psycho Billy Mims over there? He's not losing it.
Where did you go to high school?
Maple Grove. I think he's quoting something. Is that what you did for a start?
No. Yikes. Is he mad or happy?
I think he's quoting something. I'm going to trust. I'm going to start talking. All right, here we go. What does tangent start with? Starts with a what? Point. So we have a point here. Good job. Point. Okay, so point, and then it goes asymptote, asymptote. Now, when you switch x and y, okay, there's only one point here to switch, and it's what? 0, 0. So there's nothing else to switch, but there is something else to look at. So I'm going to do that in green. And then I'm going to go up the y-axis, pi over 2, down the y-axis, negative pi over 2. Okay? When you switch x and y, what do you think happens to the disco curve? It's lying down disco curve. So it's going to look like this. Let me go ahead and draw. What happens to your vertical asymptotes? They turn into horizontal asymptotes. Very good. By the way, this graph actually shows up on the AP exam quite a bit. Inverse tangent graph. So make sure you're familiar with what it looks like. I almost should probably put it on your common graphs thing because it shows up so much. But all right, so line down. All it is, it's from negative pi over 2 to pi over 2, and instead of disco curves, it's a line down disco curve. And so it's going to look like this. It's like pi over 4 is where it's going to. Yeah, watch, you'll see it. Oh, right there too. There you go. And it does reflect. It does reflect over that line 1. If you draw that line y equals x line there, by the way, it's going to cross right there, and I'll talk about what value that is. It does cross exactly over that y equals x line. Does anybody know what this value would be right here? That's your pi over 4 value, where they're equal at. Now, this domain and range. Domain, what was the domain for tangent? This is where it gets a little interesting.
Negative pi over 2 plus.
Pi over 2.
You say negative pi over 2 or pi over 2? Well, remember it keeps repeating forever. So it was, remember, domain was whatever your asymptotes were. X cannot be those. What were your asymptotes? What's your start asymptote? Give me a start asymptote. 5/2 plus what?
Pi over 2.
Plus pi k. So the domain would be x cannot equal that. Okay, remember? What's the range? All the numbers? Now you're going to love the domain for inverse tangent. Absolutely love it. Because what's the domain going to be for inverse tangent? All the numbers. The line down disco curve is going to go forever. That green one's going to go forever to the left and right. You can do the inverse tangent of anything. Try it on your calculator now. Do the inverse tangent of 1,000. Do the inverse tangent of a negative 1,000. Do the inverse tangent of 5. Do the inverse tangent of whatever you want, and it will work always.
1 trillion.
Okay, fine if you want to do 1 trillion. I'm gonna have to go check on Mark, make sure I get plugged out. All right. Range though gets a little tricky here. All right, look at it. If I keep doing this, if my domain becomes my range, then what's going to happen is you're going to have all these new horizontal asymptotes, right? There we go. You're going to have all these horizontal asymptotes. What's going to happen is you're going to have another set of horizontal asymptotes, and then another set, and then a set down here, and a set down here, and you're going to get another line down disco curve, and you're going to get all these line down disco curves stacked on top of each other, which means it won't pass the what? That's why we're only looking at one set of horizontal asymptotes, because if you do another set, automatically doesn't pass the vertical line test. So what is the range for this? Negative, be careful here. Now we're not going to use brackets. Get ready. Do not put brackets. Put parentheses, negative pi over 2 to what? Pi over 2. Memorize that. Now, why do I not include the negative pi over 2 and pi over 2? Because there's asymptotes there. And we know that when we do this, we know that there's asymptotes there. We know that it was something that made it undefined. So your calculator is not going to spit those out, unfortunately. You're just going to have to think about those and know those. And you'll have to recognize when they showed up as an asymptote. All right, tonight for homework, now that we got that done, this is me to start thinking about this and get this memorized. I want you to work on one thing before I get to the homework tonight, and I'm going to show you what you do for homework tonight, because tonight you're not going to need a calculator. But to save us some stress, tonight, focus on getting the range memorized for inverse sine, inverse cosine, and inverse tangent. Just inverse sine, what is it? Negative pi over 2 to pi over 2. What is it for inverse cosine? 0 to pi. What is it for inverse tangent? Negative pi over 2 to pi over 2. You get those memorized, it's going to be a lot easier tomorrow when I start doing the calculator ones. Now, what I want to do is shift gears, and I'm going to show you how to solve trig equations without a calculator. And it does involve inverse trig, but you don't have to think about it, because you're going to think about the way we're going to do it without a calculator. You're going to use your knowledge of the force, which is the unit circle. Okay? Here we go. Examples. Come back, board. Here we go. Solve simple trig equations. So we're going to start with simple, because they're going to get hard this week. If you're good at algebra, the good news is that without the calculator problems, you'll love the algebra. It'll remind you of being in an algebra class. There'll be a lot of manipulation, algebra manipulation, very concrete, sequential, mechanical type stuff. The calculator ones throws a whole nother, variable. I don't want to say variable. It throws a whole nother twist into it, because now you not only have to be good at the mechanical stuff, you got to be good at being able to look at the calculator, interpret what it's telling you, and then go after what you actually need. Okay? So we'll get into that tomorrow. So solving simple trig equations, there's two types. Ready? Two types. There are going to be one with infinite number of solutions, and there's going to be ones with finite number of solutions. And I'm going to do an example of each, and I'll tell you how you know which ones have infinite number of solutions and which ones have finite number of solutions. And it's really simple. You just have to read the directions. One's going to say, solve for theta, or x, whatever. That one right there, automatically you know it's an infinite number of solutions. Because when you see the second type of directions they'll give you, you'll know why. This one will say solve for theta from 0 to 2 pi. Now I'm going to explain the difference between the directions because that's the first thing you need to know. This one over here, I did not specify where theta is, where the angle is. It could be within 1 counterclockwise rotation, or it could be within 8 counterclockwise rotations, or it could be within -3 or 3 clockwise rotations. It can be anywhere you want it to be, and we can keep going around that unit circle clockwise, or we can keep going around that unit circle counterclockwise. So what you're going to do on this one is going to be a little bit different from what you do over here, because over here, and we're going to actually start with this one, because this is the easier one to deal with. Actually, they're both easy, but this is an easier one to start explaining. Come on, just stop doing that. Okay, this one's a little bit easier to start with, but let me ask you this. This means what? 0 to 2 pi. What does that mean? It means one rotation. Which direction? Counterclockwise. One rotation. Can anybody tell me why I got parentheses on 2 pi? Because 0 and 2 pi are the same thing. You don't need to be redundant. Okay? If you put 0 and 2 pi, you just put the same angle. You don't. They're not the same angle. Let me scratch that. But they are what? Same. They're called coterminal angles. They are coterminal angles. You don't need to list coterminal angles. Over here, we're going to list coterminal angles. We'll get to that in a second. So here's my example. Ready? So we're going to solve for theta from 0 to 2 pi. So first example is going to be sine theta is equal to negative root 2 over 2. Now, what we're going to do to solve this is using inverse trig. But tonight, you do not have to show the inverse trig. Because the way we're going to do inverse trig is we're just going to think about the unit circle in reverse. And you do it the exact same way you did exact trig values. You're going to do two things. You're going to figure out where it's positive or negative. You're going to figure out the reference angle, and then you're going to answer the question. But here's the deal before I get started. Can somebody tell me how many possible solutions can you get for your 6 basic trig functions? There's 6 of them. Once you get it down to the very basic trig function, no squareds, no cubes or anything like that. Once you get it down to a basic trig function, sine, cosine, tangent, secant, cosecant, and cotangent, how many possible solutions can you have in one rotation Mason? 2, up to 2. There is never more than 2. Don't you come to me and say there's 3. Don't you come to me and say there's 4. There can only be 2 when you get it down to a basic, simple trig ratio. Now, here's the thing. Some of you are going to get mad at me tomorrow because we're going to get problems that have 12 answers. Tomorrow we will have a problem that will have 12 answers. Guaranteed. And it will be from 0 to 2 pi. And we'll get problems that have 8 answers. And we'll get problems that have 4 answers. But you need to believe me on this. When you get it down to a basic trig ratio, there can only be 2. Now how we can change that is we start screwing around with the period. If you start messing around with the period, you can start. If you start messing around with the period and you say you shrink the period down a lot, like you shrink it down to where you complete 4 cycles before you get to 0 to 2 pi. If you complete 4 cycles before 0 to 2 pi, now you've got 8 answers. If you complete 5 cycles before you get to 0 to 2 pi, now you got 10 answers. And we'll deal with that tomorrow. But if you got a basic trig ratio, how many answers can you have? 2. And it's real simple. You ready? Here we go. Patrick, can you tell me where sine's negative? This is the first thing you do. Can you tell me where sine's negative? Yep, tell me what quadrants is negative in.
3 and 4.
I would write that down first. Either write it down or make a mental note. You don't have to write it down. But quadrant 3 and quadrant 4, because this is how you're going to check. You're going to know I'm looking for 2 answers. One of the answers is in quadrant 3, one of the answers is in quadrant 4. And by the way, this is so key for when we do the calculator part. If you don't get this part tonight, you have no hope on the calculator part because you do it the same way. The only difference is you're dealing with decimals and not common angles. I'm not going to give you a non-calculator problem like this because you can't do it. You cannot do that problem without a calculator because does anybody know where sine equals 1/3 on the unit circle? No, because I didn't require you to memorize that one. That one's going to have a decimal answer. And that one you're going to need the calculator for. But this one we can do because now once I know where it's negative, 2 answers, Now I just got to say, what reference angle would make sine equal to root 2 over 2? What reference angle is sine equal? Think quadrant 1. Remember what you memorized in quadrant 1. Which reference angle is sine equal to root 2 over 2? Pi over what? 4. Now you answer the question. You say, okay, theta. There's 2 answers. In quadrant 3, what's the angle with a pi over 4 reference angle? 5 pi over 4. There's 1 answer. Done. Now you go to quadrant 4. 7 pi over 4. You're done. That simple. This tonight will be simple. You'll be like, okay. And what tonight will force you to do is learn the unit circle at a whole different level. Because you can
Would
go
it be
unit circle
negative
in
5 pi
reverse.
over 4 and 7 pi over 4?
Nope, because what's the direction say? 0 to 2 pi. Gotta pay attention to the directions. Now, the next one, okay? This one is the one that people get frustrated by. But if you can't do this, then you're going to have a hard time doing the problems where we get 8, 10, 12 answers. Because this one's going to involve coterminal angles now. Okay? You got to pay attention to the directions tonight. I got 2 more problems to do. Here we go. Let's go. Secant. Here we go. I'm going to throw something else at you. Secant is equal to negative 2. Now, a lot of people are going to be like, I don't know what to do. Because I haven't showed you yet. But can anybody tell me how you might want to think of secant? Absolutely. I do not want to do secant. When you see secant, cosecant, and cotangent, you want to use your reciprocal identity and change it. So secant is really what, everybody? 1 over cosine. So we're going to do that right now. I'm actually going to let you skip this step tonight, but I'm going to show it right now. I will let you skip this step. So 1 over cosine, because I know secant is 1 over cosine. True? All right, good. Now, there's some algebra involved here. This has anything to do with trig. This has nothing to do with calculus. This has everything to do with algebra. How can I get cosine to the top? How can I just move cosine to the top? You can do that, but a better way. What is the inverse of a fraction? What is it called? Reciprocal. But if I do the reciprocal of this side, what I do to one side, I have to do to the other. Now, what Natalie is saying is she could multiply the other side by cosine, then divide by the negative 2. You'll get there, same way. But here's what I'm going to allow you to do. You ready? I'm telling you the work you get to skip. You get to skip it all. You don't even have to show this middle side. You can just say, what is the reciprocal of secant? Cosine. What's the reciprocal of negative 2? Negative 1/2. Done. You already changed it into cosine. So if I see a problem like this tomorrow, cosecant theta is equal to root 2. I can do reciprocal of cosecant's what? Sine. I can do the reciprocal of root 2 is what? Root 2 over 2.
So is that solved, like the cosine?
I've not solved yet, but I've got it to the point where I can solve it now. Now I go, all right, theta. Now here's the part. We've got an infinite number of solutions. Here's the twist, okay? We know, how many answers are there in one rotation? 2. So go after the 2 answers first. Where is cosine negative in one rotation? Be careful here. Quadrant 2. And quadrant where? 3. What reference angle does cosine equal 1/2? What reference angle is cosine equal to 1/2? Pi over 3. So now you go, okay, quadrant 2 first. Let's do quadrant 2 first. What angle in quadrant 2 has a pi over 3 reference angle? 2 pi over 3. Now stop. Now you got to give me all the solutions. So now not only do you got to give me 2 pi over 3, you got to give me every angle that's coterminal with 2 pi over 3. And how do you do that? Plus 2 pi k. You got to remember to put the plus 2 pi k on it. Now you can go to the next one. Because now you just gave me every answer at 2 pi over 3 and every answer coterminal with it. Either direction, because k can be positive or negative rotations, right? All right, what's the next one? Quadrant 3, pi over 3 reference angle. 4 pi over 3 plus 2 pi k. And there's your infinite number of solutions done. But you go after the 2. That's why I started here, because I know you can get the 2. All you got to do on the infinite number of solutions ones is just add the what? 2 pi k. Now, before you go, I have one more, and then I'll let you go, and I'm just going to kind of go through it with you real quick, and it's a funny one. Let's do just from 0 to 2 pi. 0 to 2 pi. Because everybody's going to ask me tonight, and you can email me tonight if you get stuck. Everybody say, how do I do this one? Or if it's cotangent. If it's cotangent, I don't even know if I'd change cotangent into tangent. You can do cotangent the way I'm going to show you to do tangent. Are you ready? All right, first of all, it's isolated as tangent, right? Tell me, where is tangent positive?
On quadrant 1 and 4.
1 and 3. Now, some of you might have had a hard time coming up with that, so here's what I do. Here's what I do. I'm going to tell you the secret to doing this one. Change tangent into what? And it will be a lot easier to do, because here's what you do. You say, okay, if I want it to be positive, where is sine and cosine either both positive or what? Both negative, quadrant 1 and 3. Now, here's how you do this. Check this out. This is cool. Now, I don't know if they teach it like this, but this works. It works really slick. I need to get root 3. So, you only have 1, negative 1, 0, 1/2, root 2 over 2, and root 3 over 2. What do I obviously need to use to be able to get a root 3? I'm going to need a root 3 over 2. Where do you think the root 3 over 2 has to go? It's going to have to go on top. That means if sine's root 3 over 2, what is cosine? Don't worry about negative positive. 1/2. Will the 2's cancel?
Yes.
Now, answer me this. Where is sine root 3 over 2 and cosine 1/2? What reference angle?
5 or 3.
Pi over 3. So then you answer your question like this. You say, okay, theta, ready? Quadrant 1, what's the answer going to be?
4
Pi over 3. What about quadrant 3? 4 pi over 3. And since it was from 0 to 2 pi, you just give those answers. Does that make sense? Okay, so you know how to do simple trig equations. Alright, see you tomorrow. Even though I got told by Mr. Zimmerman we're not supposed to let you go early anymore.
Yeah.